Okay, thank you for joining us today for our webinar. It's hosted exclusively by BLiNQ Networks. And as you're aware, the topic we will be discussing is private LTE for education. And your co-hosts today will be Patrick Buthmann, our VP of Sales and Business Development, alongside Radu, Selea, our Chief Technology Officer. Just to quickly go over what we're covering, we'll discuss some of the current challenges faced in the education sector, particularly in the United States, as well as the key requirements for campuses in relation to connectivity. We'll then take you through what a private network architecture looks like, and then we'll talk a bit about BLiNQ's product line, and then we'll wrap up with what a potential deployment kit looks like for any campus. My name is Mary. I'll take your questions throughout the presentation. So feel free to send your questions via the chat box and we'll answer them at the very end. Without delaying further, I'll pass it over to Patrick and he'll get us started.
Thank you, Mary. Well, as we know, I mean, with the current situation that we're facing in the world today, there are a number of challenges, particularly that are addressing the education market in terms of, students being forced to learn from home, parents staying home to educate their children, and a lot of things have not been in place in terms of even connectivity for these children to be able to, or students of all ages for that matter, to be able to further their education in times like this. And it's really exposed a lot of gaps and a lot of challenges within the education environment, not just in the US, but throughout the world. From the Center for Reinventing Public Education has provided some information for this, and only 28% of rural school districts in the US currently have an internet connection of any sort. So this makes it difficult for a lot of these rural schools to even be able to educate their children, much less in a lot of the homes that are uncovered that happen to be within that area. And some of the capabilities for remote learning, everybody's aware of, okay, what are the limitations? If you have a very long, DLC filled copper pair with DSL, you get, 1 megabit per second or 2 megabit per second because the loop length is several miles long, and that can be the case for some of these particular locations. What sort of bandwidth do you require to be able to actually provide viable real-time education that engages students as well? Things like, Zoom conferencing and Microsoft Teams and some of those types of events, even Skype, to be able to actually communicate and engage a student, because it's one thing to engage a student, through simple audio or text or email, chat back and forth, and that's one part, but there's a certain amount of engagement that comes from, real-time video conferencing and things like that require greater levels of bandwidth. And this has certainly highlighted the fact that there are, severe broadband infrastructure gaps and gaps in terms of the performance and capabilities of what's available to a lot of these rural homes and rural school districts. And the big challenge that comes out of this is, this whole situation we're in is projected to last potentially another 12 to 18 months. And who knows what may happen, again in the future. So do we really want to, put up with or have a no response or no understanding of how to be able to actually, further the education of our children in these types of environments, and be able to say, okay, how can we actually address this moving forward so that we're prepared for the next time? Because there probably will be a next time, and it will be going for so long. And for another 12 to 18 months, if we have students that are missing out on school, they're missing out on opportunities, and every year that they miss out on school, on solid education, can have a dramatic impact on their quality of life, their ability to earn, the ability to get into a good school, all those things further down the line. Next slide, Mary. So what are the key requirements to really make this whole situation work successfully? It needs to be first and foremost a private and secure network. We do not want to expose our children to anything and everything that's out there. We don't necessarily want to make it a network that is so wide open that they become distracted or, perhaps even worse, targeted through things that are not secure and not and privacy is not maintained. It needs to be simple to deploy. If it's a network that's incredibly complicated to deploy, hard to get, for residential homes connected to the school or to the network, that becomes a a big challenge to deployment and a big cost for deployment as well. It needs to be simple overall as a network. It needs to be the type of network that has sort of a network in a box type of a solution, in which it can be readily deployed by people who do not have a lot of experience or may not have a lot of experience with wireless, or even worse, private LTE or LTE in general. It needs to work with the facilities that happen to be in place. So, schools and school districts and school boards don't typically have, huge infrastructure in place, towers, 200-foot towers, 300-foot towers, lots of, cabling and power and all those sorts of things. It needs to be an infrastructure and a solution that can be put in place at a relatively low installation height, using existing facilities or low-cost facilities that can be, ideally located on school property, and again, properly secured and prevented from, from tampering, weather conditions, all those sort of things. And of course, ultimately, it has to have the performance that's required to be able to enable things like real-time video chat, online, learning lessons of various sorts, all those types of things that are a requirement from a performance and education quality perspective. And it needs to be resilient. It needs to have the ability to stand up to multiple different types of weather conditions, environmental conditions, through winter, with no trees or no leaves on the trees, through summer with a full, scenario, and even potentially through things, hurricanes and what other, sort of weather events may happen. It needs to be something that can grow and sustain and be stable throughout that entire period. So one of the things, the way we look at a private network architecture from an LTE perspective, you've generally got your base stations, would be located, say, on school property, whether it's a 50-foot, on the roof of a building, or, perhaps on a tower, if a school is lucky enough to happen to have, infrastructure facilities like a tower on site, for example. From there, you've got your really two, planes, your control plane and your data plane. For example, the two paths for data to go through the network, one of which is the management side. So things like, how you manage CPE, you manage, performance characteristics, throughputs, latency, quality control, all those sorts of things, monitoring what people are doing, where they're going, all those sorts of things. And then you've got your general data plane, which goes, traffic out to the internet or to local servers, for example, that happen to exist on, school property, and those types of things that exist. What we've done with this architecture is it's very distributed and stable and resilient. So you've got the base stations themselves. Could be our FW300i, which is our all-included model. We'll talk about that one in a couple of slides. And also an on-site access gateway. And that access gateway actually is co-located, right on the tower or right on the facility where the base stations are located. And you actually break out all of your L2, your layer 2 Ethernet data right at that point, and it can be forwarded out to the network however you wish. And that's where if you have communication to other school boards, to, again, private, servers or facilities within the school district itself, if you want to do things that are not, don't require internet access, if the applications are being hosted on the school premise itself or in a private school cloud of some sort. And then your control plane are all the things that happen in the background. Of course, your network management, things like access to CBRS SAS being the spectrum allocation services that allow you to get access to low-cost CBRS spectrum and be able to utilize that to provide these resources to the school. So it's a great overall architecture and overall system to be able to do this. And of course, all of this through a centralized, can be locally hosted or can be cloud hosted management and orchestration interface. So a single pane of glass, which you can look at everything, again, control your ability to assign throughputs, quality of service, all those things to various students and various customers along the way. It's important to note as well too that it's a very low footprint solution as well. It's not something that requires racks and racks in server rooms or even facilities located at the base of a tower. It's a zero footprint design. The baseband unit and radio head are all integrated into one unit. With the FW300i, it even includes antennas and everything as well. So it's a very compact zero footprint solution that requires minimal installation actually at the location. So an example of how this is going to look, we've run some heat maps. This is done for a couple of school districts that we've been involved with already. We based this upon their request of a 50-foot installation and a 150-foot installation. So on the left-hand side, top left corner, is our FW300i LAA. The LAA product we'll talk about in a bit as well, but that is a combination CBRS and 5 gigahertz solution that can actually do multiband and do carrier aggregation across multiple bands. So from a height of 50 feet, you're looking at good performance out to about 2 miles to exceed 100 megabits per second on the downlink side. And then to meet the 50 megabit per second, you're looking at between 3 to 4 miles to meet the 50 megabit per second downlink requirements. And these are all TCP provable numbers, not theoretical over-the-air numbers. Going up to 150 feet, the range increases, quite a bit. You're probably looking at, sort of in the 3 to 4 mile range in the 100 megabit per second territory, and you're looking at 50 megabits per second, out towards the 5 mile range. When we go into our FW600, this is a much more dense solution in terms of its ability to handle, greater density of users. So this really becomes the play when you start to look at having a larger number of students located in an area around the school board. With the same sort of heights, you have the same kind of, physical parameters in place. At a 50-foot installation with the antenna, you've got the ability to, basically, you're looking at 100 megabits per second out to 2 miles. And then, basically 50 meg out to 3 to 4 miles and 25 meg and above out to 5 miles. Again, at 150 feet, you're looking at, higher performance across the board. Basically, you're looking at 3 to 4 miles to do the 100 megabit per second. And then, looking at 50 and beyond out to a 5 mile distance. The important thing to note with the FW600 is you're effectively looking at 12 times the density for the overall capacity within an area. So you've got much more user capacity and throughput performance capable from doing that solution with LAA. So a little bit about the FW300i. This is a fully integrated CBRS base station, 3 sectors, 3 60-degree sectors and 180 degree. So if you look at the picture, that's actually 2 units mounted on a pole back to back. Very compact, again, fully integrated baseband, radio head, antennas, GPS, powered off of a single 48-volt DC power connector. Can also be powered off of AC with an external power supply. Fully, weather protected and hardened, greater than 200 kilometer an hour from a wind survivability perspective, and temperature range from minus 40 Celsius to plus 60 Celsius. I guess I'll have to do the conversion on that into Fahrenheit, but that's pretty much, can be pole mounted, can be tower mounted, can be wall mounted. So it's very compact. But the important thing to note from it as well is that it's a full CBRS macro base station. Each sector has the ability to transmit at the maximum radiated power, EIRP, as per the FCC limits for CBRS. So it's a compact base station, but by no means is it a limited performance base station of any sort. And the whole thing weighs 25 pounds. So it's really designed to be one person installable. So you can actually bring it up onto a tower, but with one person, or bring it up onto the rooftop with one person, and it can be actually installed and up and operational in as little as 15 minutes with somebody who has, you know, even a moderate amount of experience installing these sort of units. Everything within the radio itself is fully software configurable. So we support what's called carrier aggregation. And with carrier aggregation, you can actually physically and logically, really, it's no site visit required. You can actually radiate the energy from each one of those 3 individual sectors and aggregate those signals into one sector. So you can take, you know, spectrum from the left-hand sector and the right-hand sector and actually run all 3 channels in a single sector and triple the performance in that single sector simply through a software configuration change. So no physical site visit required, just log into the console and direct which antenna you want the RF energy to go out, and you can do carrier aggregation across there. The other important note too from this is that from a carrier aggregation perspective, it's one of the only solutions on the market that can actually utilize the entire CBRS spectrum. So anywhere within the entirety of 150 megahertz of CBRS is available for us to use. Next slide, Mary. So some examples of how we do this from a carrier aggregation perspective, or how it would look. For example, the ones on the top is a 3-unit configuration around a tower in case you wanted to do a combination of, if you see 2CC and 1CC, CC stands for component carrier. So 2CC is you have one sector that has 2 radios or 2 channels in it, and another sector that has 1 channel. So you can get double the performance out of the sector that has 2 channels and normal performance out of the one that has 1 channel. This would be in the case you have, you know, certain students or customers that, you know, have a greater, you know, requirement for bandwidth in that sector, or simply a higher number of users in a sector that require greater density. Again, all those changes, all those different configurations up top are all completely configurable within software. So once the equipment's mounted and powered on, we really don't need to change anything from a hardware perspective. You simply do a software change, and you can actually adapt your network as you need, as you see fit. The configuration on the bottom is 2 units mounted back to back on a monopole. So your standard configuration might be 6 sectors of 60 degrees each, covering a full 360 degrees. And each sector is giving you 150 megabits of aggregate throughput on a per sector basis. Each one's operating independently. You may then decide to do, depending upon the deployment or how students and homes are distributed around the neighborhood, do 3 component carrier aggregation in one sector because everybody's concentrated within a single 60-degree arc, and the other 2 sides you need to spread stuff around. It's all completely flexible as far as that goes. You can also even go greater in terms of density depending upon what you want. If you decide you want to do a, you know, a single, you know, reuse of one, if spectrum's limited, but you need maximum performance, you can do things along the lines of, you know, 4 FW300Is, each running in a 3CC carrier aggregation mode, each one covering, you know, a 90-degree north, south, east, west type of a configuration, but maximum performance to each one of those individual sectors based upon what you want to do. And, you know, in each one of those sectors, you're now looking at roughly 500 megabits per second of total throughput available in each one of those sectors that can be delivered, again, you know, even at a 50-foot antenna installation height, you know, basically out to 2 miles away from the school. At 150 feet, you're looking at, you know, 3, 4, and 5 miles and beyond, depending again upon the particular environment, how non-line of sight or line of sight it happens to be. It can also be deployed in our 300i LAA mode, which is a new product we've just launched. And the FW300i with LAA is a CBRS and 5 gigahertz solution that has the capability to operate independently in either one of those modes or in combination between the 2. So you can set it up and run in CBRS only mode and use it with CBRS only CPE. And then as you need to add capacity, you can add 5 gigahertz to it simply from a software change, a software upgrade, and you add 5 gigahertz capability to that. It also has the capability to operate solely in 5 gigahertz only mode. If CBRS spectrum is not available in an area, but you happen to have 5 gigahertz, or any combination thereof. So I can do even as simple as one 20 megahertz channel of CBRS spectrum, which you would pay for, and then 2 channels of 5 gigahertz spectrum, which of course are license exempt, so no cost requirements associated with those, or any combination thereof. I can do 2 channels of CBRS and 1 channel of 5 gigahertz and be able to utilize that as a means of really growing my capacity at a very cost-effective manner. And again, it's a simple software change on the unit. There's no hardware change at all in the LAA version of this one. So it allows you to use the best spectrum that you have available in any point. And the other important factor of this from a 5 gigahertz perspective is, we cover both parts of the 5 gigahertz band that are widely available, and we can aggregate any of those pieces together. So the typical challenge with a lot of Wi-Fi or standard 5 gigahertz based solutions that you'll see in the market is they just go with bigger channel sizes, 20 megahertz, 40 megahertz, 80 megahertz, 160 megahertz. The challenge is, in order to find 160 or even 80 or 40 megahertz worth of clean spectrum that is usable is very, very difficult to do. However, in our particular configuration, you're most likely to be able to find a clean 20 megahertz channel. We can actually take 2 20 megahertz channels, one from as low as 5.1 gigahertz, one from 5.9 gigahertz, and aggregate those 2 together along with a single CBRS channel and have basically clean spectrum, and with, of course, clean spectrum, maximum throughput for a particular environment. The FW600 is the next step up from the FW300. And again, this is a split design, still a fully integrated radio head and baseband unit, but we utilize our multi-beam, our patented multi-beam antenna. And with the multi-beam antenna, you now actually triple the capacity in any particular sector. So you've actually got now 3 individual beams, each of which can go from 1 component carrier up to 3 component carriers. And in any particular sector, you're now looking at potentially 1.5 gigabits per second of available capacity within an individual sector. So as we start to get denser and denser, and you have more and more users contained in an area and a greater requirement for throughput in any particular area, you can actually, simply just start adding individual carriers to each one of those beams and start to grow that capacity and be able to, satisfy more and more needs moving forward in the future. Again, as per the CBRS, standard, you've got full power CBRS. You've also got great uplink performance from the 600. And the uplink performance is really what determines how well each one of those subscribers can perform from an uplink side. So you've got an extra 5 dBs of uplink gain on each one of those. And then I believe the next should be the LAA. So as we start looking at with LAA as well, we start now looking in LAA at a 6-beam solution. So the FW600 now starts to look at 3 beams of CBRS. Well, actually 6 beams overall. Each beam is a combination of CBRS and LAA. So you potentially have a solution that scales up to 24 beams across an entire 360-degree cell site, 4 sectors, with great coverage and capacity across the overall thing. You're looking at scaling up to solutions that look at potentially 12 gigabits per second out of a single cell site. We also have solutions in band 41. The FW600 exists in band 42, 43, 48. In the US, band 48 is CBRS, but also band 41, which is the education band. So the FW600 in band 41 as well. There is a band 41 version. So if there's a requirement to use band 41 to provide education, the exact same technology, exact same capabilities exist from a band 41 perspective, 2.5 gigahertz. as it does with CBRS in 3.5 gigahertz. And here we talk about, again, some greater details on the FW600 LAA. This is where we talk about 6 beams per sector, 24 beams for an overall site. Scales up to, again, 12 gigabits per second. You have the ability to potentially even get down to very narrow reuse levels. The great advantage from doing this from an LAA perspective is you minimize the use of relatively low-cost CBRS spectrum, but you can maximize the availability of CBRS spectrum in the event that it's highly contested within an area, and then use 5 gigahertz spectrum as available to fill that in and keep that performance high. Next slide, Mary. Of course, wireless network is only as useful as the CPE that go along with it, and this becomes a critical element as well. You know, with the right mix of CPE and the right type of high performance CPE, that really makes or breaks whether the network itself is successful. You can have the greatest base stations in the world, but if the CPE are not up to the task, the entire solution tends to fall apart at that point in time. So you really want to make sure that the solution is there. And there are 2 parts that are critical within the CPE side. One is the CPE performance itself and its capabilities, but the other part of it as well is how easy is it to deploy this, and how easy is it to align these things. When you're in the field, it's not like it's okay, plug a cable in and how do you move forward from there. You need to have the ability to be able to predict what type of performance you're going to get from a particular environment or a particular location or residence, and how long does it take to actually do that? If it takes you 8 hours to deploy a single site, that doesn't become a very cost-effective solution to deploy. You ideally want to be able to deploy, you know, any customer site in 60 to 90 minutes and be able to move on from there. Next slide, please, Mary. So if we start talking about this, we've released a product called Pointlink, and it works as an element of our NetLink network monitoring or element management solution. And what Pointlink does is it's a completely independent power supply, alignment tool, prediction tool, and all of these things wrapped into one. And basically what it does, you've got a bracket that's designed for our CPE that actually allows you to do pan and tilt conveniently with a gyroscope, you know, or an accelerometer on the back that allows you to actually be able to align it, point it, in conjunction with a smartphone app that would run on, right now, Android phones. It will be coming to iPhones as well, that actually will give you accurate predictions before you've even powered up the CPE of what type of performance you can get from any particular site. So based upon you know, predictions and our modeling engine, you know, the school or the integrators can actually go into a site and say, I know that at Johnny's house, he's going to be able to get 100 megabits down and 20 megabits per second up. And at Susie's house, he's going to be able to get 50 megabits down and 5 megabits up, and so on and so forth. And be able to actually go and say, here's what we need to do to be able to make that alignment work. Here's the best part of the house to install it at. Here's the direction you need to point at. And here, in fact, here's the base station that you actually need to be able to point at in order to be able to make that happen. And all of this is part of our Pointlink solution, having those capabilities. And the critical elements behind this are, again, as we talk about this, the real cost in any one of these networks is really driven around the CPE and the operational costs of actually installing them, getting them up and running, figuring out if you can even provide service at little Johnny or little Susie's house, for example. If you actually know that you can provide service at their house, it makes the truck roll to be able to actually deploy at that house infinitely more viable, because now you know that you have a paying customer that will happen at the end. You don't have to actually roll the truck, find out that that's not really going to work here, and then kind of abandon that, and you've spent money for no potential, you know, revenue along the way. So you have the ability to make that estimate up front. You have the ability to kind of survey the territory early on and say, yep, this is going to be a viable solution. And on top of all that, you're not having an installer that's going to spend 4 to 8 hours at every site optimizing the installation. the installer can actually optimize the installation, have the alignment and everything done, know what they're doing, power it up off of the Pointlink tool. The Pointlink tool has the ability to actually power the CPE itself without even having to drill a hole in anybody's house and run power and run cables inside, anything of the sort. The Pointlink tool actually has the ability, it's got onboard batteries that will power the CPE and be able to actually get that whole thing up and operational, including registration with SAS. So all of that can be taken care of before you've even physically mounted anything at the customer's house, and be able to actually say, okay, here it is, perfect, it's done. Now it's up and operational and becomes the installation. So the ultimate idea and the ultimate goal behind Pointlink is to make the installation of CPE as simple and as time effective as possible. And we're really talking about something that takes, the standard installation time tends to be 4 to 8 hours. 8's a little on the high side. 4 is average to low average from what we've seen in the industry. And we're driving that to basically be 60 to 90 minutes. So ultimately you can do 4 to 8 times as many installations in a day as could have previously been done without a tool like Pointlink. Next slide, Mary. All of this, of course, is critical when you have a management suite itself that you need to be able to actually, take a look at and monitor your network, see what's going on, see where the faults are, see where the performance is, see who's off, see who's online, all those sorts of things, make optimizations as necessary. So NetLink Management Suite is designed to manage base stations and CPEs, the whole bit, all your control plane details, host the details for the Pointlink app to be able to actually say, okay, here are the performance characteristics of these things, how do we optimize it, et cetera. All those things are in there, including even future extensions for a self-optimizing network. And a self-optimizing network being one that says, okay, I know where I've got interference, I know where I don't have interference, what do I need to do in terms of channel planning and changing, turning up power, turning down power, doing all those sort of things to optimize and maximize throughput and performance in any one particular area. So how do I be able to take all of that, coordinate it, and from a central location say, I'd be better off if I move this particular sector off of channel X in 5 gigahertz to Y in 5 gigahertz because I know I have no interference in channel Y, and then I'll make my adjustments to maximize network performance and improvement overall. Next slide, Mary. The other thing that's critical in all this, and this is really where we'll start to wrap things up, is what does all of this cost? It sounds great, but if it's $1 million per school, that starts to become something, or $10 million per school, everybody starts to go, hey, that's, starts to become horrendously expensive for my little school that has, 200 students in it or something like that. The important thing to note about, BLiNQ and our overall target is we aim to and we succeed. We basically, in all the competition, is as a North American manufacturer, our objective is to offer the lowest total cost of ownership for a 5-year to 10-year period of any vendor out there on the private LTE space. Your typical deployments to look at from a school perspective, you're looking at somewhere between 2 to 6 FW300Is, depending upon density of the deployment into school, density of students in the area around it, the amount of coverage you want to do, how many CPEs, depending on how many students are at the school, could be 200, could be 500, could be more than that, depending on how, rural or isolated or, centralized the school is, for example. With NetLink, it brings an integrated management portal. So all of your data and all of your tracking statistics, et cetera, located within a single centralized environment. And then, of course, one of the most complicated things behind any of these wireless networks, particularly LTE, is the fact that you've got a well understood centralized packet core, the evolved packet core. With an access gateway that's broken out on a per, tower or pole or building location, so that in the event of any backhaul links get cut, you only lose that one particular tower or installation or base station, you don't happen to lose the entire network. So for example, lightning strikes one tower, but doesn't take out anything else, you're not losing the entire network along the way. If something happens that you lose power at a single school, but if you've got a number of schools that are participating in this particular private LTE network, you have the ability to support that. Some of the other things that we really didn't talk about on the CPE perspective, to bring that up as well, one of the great things about LTE is the fact that it is a worldwide industry standard. So this also brings in the ability to bring other devices into the fold as well. So if the school wanted to do things like, say, provide iPads that have CBRS support in them, they have the ability to do that, and they can connect with the correct SIM cards and the correct programming and the correct authorization into this private LTE network, and the school can then do things to say, hey, we enable our students to work from anywhere. This is another great advantage, you know, from an EPC solution in terms of being able to say, okay, these students have iPads and they can actually use those iPads connected to the school's network, whether it's in the school property or at their homes over Wi-Fi or at their homes over LTE, or even out and about. They're at the local stadium or in a park, whatever they are. If they're within the coverage area, those students can potentially engage and use those facilities, access school resources virtually from anywhere within that network with that full support of an LTE environment. With that, Mary, I think, any questions?
Yeah, that brings us to our Q&A. So we've been answering them throughout the presentation, and all the answers are visible to you all, but we can give you a minute to submit any other questions you might have, and we'll be on standby to answer any additional questions.
Look like we're seeing a couple of questions pop up there. So Reese, about your question, I hope I got your name correct, and it's Reese. Yes, I mean, the great thing again about a 3GPP standard is the fact that it is standards based. So we've worked with all kinds of vendors, you know, from our CPE to other base stations and our base stations to other CPE. Again, that's the fantastic thing about LTE is it's an industry-wide standard. And that's where that capability comes from. So yes, fully interoperable. As long as everybody adheres to, you know, 3GPP standards, there's full interoperability.
We also have a question from Stephen.
Oh, sure, Stephen, put me on the point. Stephen and I know each other from way back when. Yes, so MSRP on the FW300i is $7,000 all in. So that's our list price quantity of one. So if you have a $7,000, call it $14,000 for a site of two FW300is back to back, for example, and your typical CPE cost, a list price, for example, on CPE is $350 in quantities of one. Typical deployment costs are obviously go down as volume goes up, you know, from a CPE perspective. So, you know, base stations, you know, $14,000 for a base station. That includes basically everything. Packet core depends upon the volume and the size of the packet core. You know, that can range anywhere from you know, call it $1,000 per site, for example, to $30,000 depending upon scale and features and functionality, whether you want a fully centralized solution, a distributed solution, levels of redundancy, how many users, all those types of things. But you could deploy, you know, typically a full network of base stations and CPE. So two base stations, for example, to cover 360 degrees, and you know, 200 CPE at say an average price of $300 each. What's my math? So you're less than, you know, $75,000 for for a network, for example. That's just a ballpark at again, these are list prices, typically deploying something like that. Hopefully that answers your question, Stephen.
We have a question from Abiola. Is the EPC license-based? If yes, what is the modality?
So it depends on what configuration there is from an EPC perspective. We have a number of different configurations. Our embedded EPC, which we really did not talk about much, which runs right on the base station itself, it's typically a one-time license. We have a centralized solution that is based upon a combination of base license plus user count. And so that the price of that depends on the number of users that are involved within the system. And then we're also working on a distributed system that will actually run on a network appliance that will be hardened, outdoor hardened for tower deployments. That one will likely not be a license-based solution. We're not entirely sure how that's going to be worked. It's actually part of Facebook's Magma project. So we're actually working closely with Facebook on the implementation and the rollout of that one. But that one's not ready for market yet. We anticipate that one being market ready by Q1, like the start of 2021, at the end of December, the start of January. Expect that one to be ready for market. Question from Wade, expected setup and integration time installing each CPE. With Pointlink, we think it can be as low as 60 to 90 minutes, depending upon, experience and any sort of challenges, those types of things up front. Typical deployment time without it is generally, between 4 and 8 hours. Again, 4 on the low side, 8's probably on the high challenging side. I would say, 4 to 5 times is typical from what we've seen with our partners in the industry. Typical deployment time from a wireless service provider basis is about 4 hours. So with Pointlink, we expect that'll be, 60 to 90 minutes.
Yeah, so Pat, to add to that, obviously it all depends on the hardware engineering that needs to be done on the side, but from a Pointlink perspective, the process of picking the spot, testing the spot, alignment, CBRS registration and everything. So CPE is on, speed test, we are talking about anything from like 15 to 25 minutes. So that's all. The rest is the civil engineering, which is to attach the pole to the roof or wherever, to harden the installation, place, and also to connect to the customer premises power source. Because all this exercise, it's going when you are connected to the Pointlink box, so you don't need to run cables or anything else. So it's pretty short. That includes CBRS registration and everything. So including speed test, that you can run it from the app. You don't need a computer or anything else. It's pretty fast comparing to, what we are used to do usually.
So Wade, I also saw you ask the same question from a base station side. You can, the base station configuration, for example, in a lab can be as quick as 15 minutes to configure the base station. It's very, very quick to get a base station up and operational from a CBRS perspective. Obviously, the physical installation time depends on, is it on a rooftop, is it wall mounted, or is it on a tower? There's some certain, civil requirements in terms of saying, okay, hey, it's going to take me half an hour to climb 300 feet up the tower. So that has to get factored in. But configuration time of the base station itself typically is about, 15 minutes if you know what you're doing. I saw your question about roaming in the case of unmanned trucks. Yes, roaming is supported between sectors and between base stations. We support both S1 and X2 roaming within the platform itself. So X2 roaming from sector to sector within a base station, X2 roaming from base station to base station, and also S1 roaming from base station to base station as well. That's all fully supported within the box.
And from Brian, we have a question.
What type of network monitoring availability SLAs do we provide? SLAs can be discussed on a case-by-case basis. We do offer a full remote monitoring solution as well. So we can actually, you know, if customers are willing to, you know, have us monitor their network 24/7, we can actually monitor their network 24/7 and actually alert them of any issues, service and support type things, any of those types of things. We can actually do that, you know, 24/7. From an SLA perspective, it, you know, depends on what the customer wants in terms of specifics. Say if they want things like, you know, 15-minute response time, 1 hour response time, all those kind of things can be discussed on a case-by-case basis. Buthmann, yes, we actually are working with Magma currently. So in terms of online charging function and policy control and routing functions, that depends upon the EPC, but typically online charging and PCRF are built into the EPC solutions, yes. The band 41 device, yes, single eNode B, so FW600 band 41. The list price on the band 41 FW600 is $9,000 US for quantity of one. That's not including antennas on the FW600. The FW600 has external antennas. Typical antenna costs will be, you know, anywhere from a few hundred, depending on type of simple antennas to multi-beam antennas. That would be, you know, $1,000 to $2,000. The X300i, the 3-sector, you know, micro cell, if you want to call it that, or small cell deployment. List price on the X300i is $4,000 list price for an outdoor deployment on that one. So max distance from the 300i to the CPE, Calvin. Typically, this can range. It really depends on, it's kind of like saying, what is a hen weigh? It really depends upon what the environment is like in that situation. Clear line of sight. We've actually tested with a large tier 2 operator in the US last year outside of Omaha, Nebraska. They were actually testing our base station and our CPE out past 16 miles. And at past 16 miles, they were still doing exceeding 25 by 3 service. They were doing 28 megabit per second down and 3 megabit per second up at a 16-mile distance. Typical deployments that we see in the industry is in the 3 to 5 mile range, typically in a non-line of sight type environment, and that's maintaining between 50 megabit per second and 100 megabit per second downlink speeds. Yes, Tom, we have pictures of deployments of the FW300i. We can get those to you if you'd like. I think reach out to Mary and she'll be able to get some of those pictures to you.
Yep, absolutely.
Abiola, the cost of the FW600 in band 42, 43, and band 41, the high power unit is $9,000 US for the FW600 high power variant. Again, that's band 42, 43, and band 41. The band 48 version is a little bit cheaper at $7,000. Indoor CPE is price is still to be determined on the indoor CPE. This will depend upon how successful some of our early trials with indoor CPE are. Indoor CPE at CBRS and 3.5 gigahertz is really dependent upon what the buildings are structured like. You know, wood, for example, is much, you know, wood and glass is much more, you know, usable, for example, than concrete and steel and some of the other things. So it really depends upon the environment for that. But I don't have a price on the indoor CPE yet. But it would be probably a little bit less expensive than the outdoor CPE. So it should be sub $300 in low quantities. Yes, I mean you can deal with BLiNQ directly. We have a salesperson based that covers EMEA. So Buthmann, well, we can get you in touch with them, and we sell direct. Yes. Joe, what's the good RSRP for a good connection? We have a very, very sensitive radio. We have installations, for example, with another large tier 2 carrier in the US, in which, now again, Radu, correct me if I'm wrong, but I believe we've seen RSRP below neg 125 RSRP.
Yeah, actually, we have a site where all the users are below -125. I would recommend to have a, because, you know, it also depending on the weather and the wind and stuff we can maintain a stable connection at -125. No problem. We even can go beyond that, but it's already, how to say, every weather change, it might affect stability, but at -125, we are confident it's stable.
So Abiola, one more question on that one. Our advice is, I mean, for 3.5 gigahertz to use outdoor CPE, generally as a rule, but it depends upon the distances. So, you know, if you're looking at distances half mile or less, indoor CPE can potentially work fine. Again, depending upon what the type of, you know, structures of the houses are like, and the buildings, you know, steel and concrete and things like that will tend to have, you know, more detrimental effect on the RF performance of an indoor CPE than say a wood frame house would do. So it really depends upon what that's like. Outdoor CPE, you can almost always guarantee, you know, a means to get a solid, stable, reliable connection from an outdoor CPE perspective. As to VoLTE support, we don't support VoLTE at this point in time. We have the capability to be able to support VoLTE, and we are, you know, it is on the roadmap to look at doing, you know, certain requirements for VoLTE support. Really, most of our customers so far have been interested in data roaming primarily and doing, you know, voice over IP rather than voice over LTE. Obviously, voice over LTE requires a whole IMS infrastructure backend instead, and that becomes a much more complicated solution overall. But VoLTE support is something that is on the roadmap to be able to do, but it's not currently supported in the product at this point in time, but it is on our roadmap. So it would be a software upgrade to do VoLTE support.
Wow, there's a lot of questions. Thank you all for being so engaged.
Yes, Wade, I got sorry, Maria. Wade's got one more question.
No,
yes, we've actually tested with a number of other vendors of all packet cores. We've tested with Metaswitch, Affirmed, Mavenir, Ericsson, Cisco's Starent core, Quartus, Atacore, Druid. Trying to think of who else we've done some testing with. IP Look, obviously Facebook's Magma. So we've done testing with all of those. So with an outdoor antenna or external antenna, for example, an outdoor CP, yeah, I mean, it's certainly a possibility. For example, I mean, our particular CP at the moment having fully integrated antennas. There's no reason we couldn't look at doing an outdoor CPE, you know, with external antenna connectors to be able to connect to something, you know, like an Omni for your particular use case, as I understand it. You know, Wim, your particular use case, for example, in the trucks roaming around the port of Rotterdam, I would understand that would be.
Yeah, though probably I would suggest that at least an as good idea would be to have, if the use case, you know, makes sense to have basically the indoor CPE architecture just with a ruggedized enclosure, because you already have 360 degrees and you have multiple antennas connected to the you know, it's very good for the let's say a multi-path and the 360-degree environment. I would say that would be probably easiest way. But both can work, definitely.
Any more questions? We've got 3 minutes left. All right, folks, thank you very much for attending. Hopefully we answered all your questions. Hopefully this was informative and educational for everyone. And again, thank you for attending. Mary, thank you for setting this up and arranging it. And as always, if you have any further questions, feel free to contact myself, Radu, or Mary, and get in touch with us, and we'll be happy to answer your questions and address them as a, offline one-on-one.
Thank you, everyone. Thanks, Patrick and Radu, for answering all the questions. And this is our contact email if you need to shoot us any questions. And you also have my email from the webinar invite, so you can respond directly to that, and I can redirect your questions accordingly. So once again, thanks for your participation, and hopefully you can join us again for our next one. Thanks all.